What's up, everyone? Welcome back. Patrick here. Moving on to another question. This is a fairly cool one dealing with quadratic. So the parabola y equals ax squared minus 33x minus 54 has an x-intercept at a value of 9 over 2 or 4.5, and we have to find the other x-intercept. So notice how the parabola, in this case that we're given, there is a constant that we don't know, or a coefficient that we don't know. There's an unknown here, this a value. And so if we can find that a value, what we can do is then have the full parabola, and then we can go and try to factor it to find that other x-intercept. So we're told the other x-intercept is 9 over 2, meaning that there's a point on this graph that has a coordinate of 9 over 2 and 0, or 4.5. and 0. So what we could do is we could plug in 9 over 2 for the x values, we could plug in 0 for the y value, and then solve for that a value. Notice that then we will have one unknown in this equation over here, right? This a value is the only one that's unknown. So if we expand everything, we'd have 0 equals a. 9 to the power 2 is 81, 2 to the power 2 is 4, minus 33 times 9 would give us what? 297, that's going to be over 2, and then we'll have minus 54, like that. Now, multiple ways you can go and solve this. Personally, what I'm going to do is I'm going to actually multiply everything by the lowest common denominator. So notice here, this we could rewrite as like 81a over 4. This 0 is like over 1. This 54 is like over 1. We can multiply everything by the lowest common denominator to get rid of all the fractions. Okay, you don't necessarily have to do that. One other way you can do it is you could combine these two into one fraction, bring it over, then you could cross multiply, solve for the a value. Whichever way you do it, just make sure you're getting the same solution that I am. What I'm going to do is I'm going to multiply everything by 4. To get rid of these denominators. 2 goes into 4 twice. And so we'll have 4 times 0, which is 0. Then we'll have 81a over here. Minus 2 times 297 would give us 594. Minus 4 times 54 would give us 216. Like this, and then over here, what we can do is just collect like terms. These two would net out to 810, right? Minus 594 minus 216 is negative 810. Bring the 810 over, so we'd have 810 equals 81a. Divide both sides by 81. We end up with an a value of 10. Right, so we have here this a value of 10. So now we have the full quadratic, right? We end up having 10x squared minus 33x minus 54. And then from here, what we can do is we can now factor this. So notice initially we can't take anything out. There's no common factor between 10, 33, and 54. So let's go into decomposition. So the a value is 10, the b value is negative 33, the c value is negative 54. So the ac value would be negative 540. What two numbers multiply to negative 540 and add up to negative 33? And if you do some trial and error, those two numbers are going to be negative 45 and 12, negative 45 and 12. So then what we could do, let's take this quadratic, let's factor it. So we'll have 10x squared, decompose that middle value into those two values. Like that. From these two, we could take out a 5x, so we'd be left with 2x minus 9. From these two, we could take out a 6, so we'd be left with 2x minus 9. And then we could take out a 2x minus 9, and we'd be left with 5x plus 6, like that. Okay, so this quadratic factors into those two right there. And then from there, we could find the intercepts, the x-intercepts. We plug in 0 for y. And notice what happens. This 2x minus 9, when is that going to equal 0? That's going to happen when x is 9 over 2, which is already, as expected, one of the intercepts that we were given. So it makes sense that one of the factors is 2x minus 9 when we factor it. It's a nice little check within the process of whether you're on the right track. And then the other x-intercept, which is what we are looking for, would come from this factor. That's going to happen when 5x is negative 6. That's going to happen when x is negative 6 over 5, right? Negative 6 over 5. And 0 would be the other x-intercept that you're looking for. So that would be the answer to this question. So fairly unique one. We first had to get that a value of 10 with this point, plugging in this point for the x and the y's. Then once we got the 10, we can factor it. And then once factored, we can get the other x-intercept.